Sripriya VP, first MCA. Today I am going to discuss about the topic process management, process scheduling, inter-process communication, communication with client-server systems. Introduction. Process management, handling of process by OS, main functions, creation, scheduling, execution, termination. Topics covered by process management, process scheduling, inter-process communication, client-server communication. What is a process? A process is a program in execution. Process is more than a program code, which is same time known as a text section. Basic components: code, data, stack, program order. Here code is the actual executable instruction of the program. Data store global variable. Stack it is used for function call. Program counter holds the address of the next instructions to be executed. What is a process scheduling? Process scheduling is the mechanism by which the OS selects a process from the ready queue and assigns the CPU. Here process is new, ready, running, waiting, terminated. New എന്ന് വെച്ചാൽ this is the initial state when a process is first created. Ready, the process is waiting to be assigned to a process. Running, instructions are being executed. Waiting, the process is waiting for some event to occur. Finished, the process has finished the execution. Here this is the diagram for representing process states: new, terminated, ready, running, waiting. Components involved in process scheduling. Ready queue is a data structure that holds all process ready to run. Scheduler, a system program that picks the next process. There are three types of schedulers: long-term scheduler, short-term scheduler, medium-term scheduler. The long-term scheduler, also called the job scheduler, is responsible for deciding which process should be admitted into the file system for execution. The main job is to decide how many processes should be admitted into the main memory. Next, the short-term scheduler. Short-term scheduler, also called the CPU scheduler, is a part of the operating system responsible for selecting which process should be executed next by the CPU. This scheduler uses various CPU scheduling algorithms like FCFS, SJF, priority scheduling. The main goal of the short-term scheduler is to improve CPU utilization and system responsiveness. Medium-term scheduler or swapper, used in swapping, temporarily remove process from the memory to reduce multi-programming. Types of scheduling: primitive scheduling, non-primitive scheduling. അതിൻ്റെ നോൺ പ്രിമിറ്റീവ് ഷെഡ്യൂൾ എന്ന് വെച്ചാൽ എ റണ്ണിങ് പ്രോസസ് cannot be interrupted. CPU is released only voluntarily. Example FCFS. Primitive schedule എന്ന് വെച്ചാൽ OS can interrupt a running process used in real-time systems and modern OS. Example round robin SRTF. FCFS, first come first served scheduling. Definition: FCFS in the simplest CPU scheduling algorithm. Processes are executed in the order they arrive in the ready queue. How it's work: the first process that arrives gets the CPU first. The next process must wait until the current process finish. It's non-primitive. Once a process starts, it runs until the completion. Here this is the example of FCFS. Suppose process arrive in this order: P1, P2, P3. P1 burst time 5, P2 3, P3 8. Execution order is P1, P2, P3. Why process scheduling is important? Ensure efficient CPU usage, supports multi-programming, allows multiple users process to run together, prevents one process from the monoprogramming CPU, makes system responsive and fair. Next topic is IPC, that's inter-process communication. Why IPC? Processes need to exchange data, coordination and synchronization, resource sharing. There are two types of IPC: shared memory and message passing. Shared memory is a type of IPC mechanism that allows multiple processes to share a common memory space. Key characteristics: shared memory space, direct access, synchronization. Message passing IPC is a type of IPC mechanism that allows processes to communicate with each other, sending and receiving messages. In this approach, processes do not share a common memory space. Key characteristics: message-based communication, no shared memory, synchronous or asynchronous. Example: pipe, message queue, remote. The topic is client-server system. A client-server system is distributed computing architecture that separates the application logic into main components. A model where client and server. Client request services, server process and response, common in web apps, cloud services,